Okay, so this tutorial is going to look at how to create the special levels from Sonic 3, or whereas that used 2D imagery to simulate a 3D environment. We'll actually be using a 3D environment with 3D models, but it's going to be the same idea where you have a character running along the surface of an orb, and they have to pick up coins or whatever, pick up rings, and avoid obstacles. So far, the only thing I've done, and I didn't bother recording it because it's tedious, all I did was take some of the built-in 3D components, the cube, sphere, cylinder, and I just made this little character. There's no animations or anything. It's meant purely to be placeholder. So what we'll do is as we progress, we'll actually put in a character who has run animations and things like that. This is just simply to have something in place to wrap the code around. Okay, so what are we going to do? First, we need to create the orb. So let's go up to Game Object, 3D Object, and we'll choose Sphere. And this, for whatever reason, showed up at a really random position. So let's set it to 0, 0, 0 for the moment. And we're going to make this thing huge. Let's make this like 30 by 30 by 30. Let's zoom out. Move this away from the camera. And then we click on the camera to see what it looks like. So let's move the orb down a little bit. Click on the camera again. And let's move the camera in. And it's just the balance of exactly what perspective you want. I guess that's okay. We really don't need to see the entire horizon. Now, the next thing we're going to do is we're going to give this a material. We're just going to use a solid material. So let's right-click, choose Create, Material, and we'll just call this Green Matte because it's going to be a green material. We click on Albedo here. We choose Green, and then just drag and drop it onto the object. Click on the main camera again, and that's what you're looking at. So the first thing that we want to do is we want to make this, because it's going to be similar to like an endless runner, except it's on a finite area. And that is, it's going to automatically scroll. Whether you're going to be scrolling forward, but you're going to be able to turn left, turn right. But what really happens is we're probably going to rotate the orb itself left and right. We'll see when we get into the coding. But your character is basically going to be static at the bottom of the screen. So, first thing to do to make this orb rotate, add component. Oops, sorry, let's go to the sphere. I was still on the main camera. So let's go to the sphere, add component, physics, rigid body, and this allows for the application of physics. Get rid of gravity because we don't want the orb itself to move, because it would drop down off the screen. And then you're going to right-click, choose Create, C# script, and we're going to call this OrbCon, short for Orb Control. I'm going to click on the sphere. We're going to put the script on the object. Go ahead and double-click on that script. Now what we're going to do is we're going to put in a command in the start section. The start section, as the code states, that it occurs only at the initialization. So say you want to put something in motion at the beginning, or you want something to be instantiated at the beginning, you put it in the start section. So, get component, rigid body, and it is angular velocity. So by angular velocity, it is going to be rotating on one of its axes. So if you just use velocity, you'd actually be moving it in the world space, along the world axis. So it would actually move up, down, left, right, forward, backwards. With angular velocity, you're creating rotation. So equals new vector 3, and we're going to have it move just on the x-axis in a negative direction. We're going to use a very small number, negative 0.2. Since it's a decimal, you have to put in the letter F. Why? Because it's unity. Something about the decimal point confuses it, so you have to put in the letter F. And we're not going to have it move on the other axes yet. So we save that. Okay, no errors. Now, because this is an orb, we really won't be able to tell that it's rotating. So for the moment, I'm going to attach an object. It's not going to be permanent. We'll delete it. But it's going to demonstrate an important functionality. So the orb itself is going to be rotating. That's going to be the actual movement. Your character is just going to be idle, hovering just above it. All the objects in the environment are going to be attached to the orb. So trees, coins, landmines, whatever, they're all going to be attached to the object. So since they're attached to the object, well, the object, or the sphere that is, they're all going to be attached to the sphere. When the sphere rotates, everything else rotates. So you don't have to do any kind of complex calculation. The rotation is going to be taken care of for you. So it's a very powerful feature. And the way you do it is you just drag and drop the objects that are to be attached onto the sphere. So watch. So game object, 3D object, and we'll just use a cube. We'll move that cube up so we can see it's poking out there at the top. Now you take the cube, drag and drop onto the sphere, and see how there's like an arrow now? It's a child to the sphere. So the sphere moves, then the object moves. And that handles so much of the animation for you. You're just going to attach everything to the sphere rotates, and Unity does the rest for you. Now, as I said, this cube is temporary. It's just to demonstrate that the rotation is working. So let's go ahead and run this. Actually, because of the edge, you could see that it's rotating, and there's the cube. So that's one of the problems, is that it doesn't have really high fidelity, so you've got these corners, but that's okay. Once you add trees and things like that, it won't be that obvious. Not to mention that you might be able to import a higher fidelity object. But again, you did see the cube move. So now, let's take our little person, drag and drop them into here. And now we're going to rotate the camera because we need to see him or her. Okay. So to slide the area around, and just so you know, this perspective does not impact what the player sees at all. You'd actually have to move the camera itself. So that's just grabbing the hand and sliding the area around. If you right-click, that's what rotates the developer perspective. All right, so let's take the person. And now that I've put it in the scene, I'll just show you. Like I said, I just took some of the primitives, put it together to make a person. Now, the camera is at 0 on the x-axis, so this has to be 0. And it is, let's see how this looks. Okay, so the person's huge. So what we can do is we can just shrink them. So we can scale. Let's see how they look now. Okay, that's better. Slide them down so they're closer to the ground. All right, that's just about right. Move them a little bit closer. All right, that's it. I'm not going to tweak his position or her position anymore because, like I said, she's just placeholder. This is just demonstrating the basic functionality. Okay, So one of the things that you can do is they're facing directly forward. You could actually like maybe tilt them a little bit on an angle. So that, using the rotation tool up here, I believe it's this angle that we want. So I rotated them about, let's make it like -6 degrees. Let's make it about -9. Okay. Now, because of the unevenness of the surface, you can see a problem, and that is that the shadow fluctuates back and forth. So that's something that you really don't want. So there's a couple of things you can do. You can have it not cast shadows, not receive shadows. Take a look at the direct light. Let's see. So shadow type, no shadows. There we go. So no shadow. Okay, so we have our character and we have the rotation. Now we're going to get rid of that cube. Like I said, that was just placeholder. Now let's put in an object. So I created, using Paint 3D, an evergreen. Using Paint 3D, you just have to make sure you save as FBX. That is the format that Unity understands. Just drag and drop it. And now we have our evergreen tree. So with placement, okay, because it's a curved surface, the first thought is, well, how do we do this? It's not going, how do we get the angle exactly right? There's actually a really easy way to do it. And that is the sphere, okay? We know where its center is. 0, -6.3, -6.35, and let's just make that 10 even. So the horizontal, so the x-axis, and the z-axis, that would correspond to any point, okay, in the dead center, because that's the dead center. So it's just the y that changes. So if you put something at this coordinate, excuse me, this position, minus the y, so if you put something at 0 and 10, then what's going to happen is it'll be the dead center. So we take our tree, it's going to be enormous because there's a scaling issue when you make the FBX in Paint 3D. So it changes to like 0.01, apply. It's way too big. So let's make this 0.04, apply. That's better. So like I said, you're going to take that and you're going to put it at 0, 10. So it's at 0, 10. So you now know that it's at the top point. It just needs to be moved up so it's touching the ground. Touching the surface, I should say. And you can see it's disappearing now. And by doing that, it'll have the right rotation. So what happens, you just keep rotating the orb, putting something right there, rotate it again, put something there again. So I'll demonstrate. So we take our orb, our sphere, and we rotate it. Whoops, sorry, I forgot a step. Take the evergreen, drag and drop it onto the sphere. So we rotate our sphere, and it moves. So now, again, you just take your evergreen, drag and drop it. You don't have to shrink it this time because you already shrunk the base model. Again, 0, 10, Make sure it's just sticking out of the ground. There we go. And so now, as you can see, this one's tilted properly, and this one's going to be tilted properly. Now what we're going to do is we're going to take this, and we're going to actually rotate everything over to the side a little bit, because they're just going to come on down right through our character. Sorry, I, again, forgot to take the evergreen, drag and drop it into the sphere. Grab the sphere. But it's a good preview, though. It demonstrates that this functionality works. All right, let's go ahead and run it. There's the trees passing you. Now, before we go any further, let's save our work. So let's go up to File, Save Scene, and let's call this World 1. Unity breaks projects up into what's known as scenes. A scene really corresponds to a level. So if you think of your old side-scrolling games, level 1 would be a scene. Level 2 would be a scene. A main menu would be a scene. So it's basically a collection of related functionality. We'll go into scenes more later. That's just explaining that it's not just a matter of saving the project, that you're actually breaking this down into kind of logical components. You're basically breaking this down into what would be a level, or like I said, or a menu, that kind of thing. Okay, so now what I said is we want to be able to control the world. So it's kind of an illusion. Your character is supposed to look like they're running, but it's really the world that you're controlling with the rotation. So what we're going to do is in this script, we said, okay, it's always moving this way, but we're going to want it to be able to rotate left and right, okay? So to make it rotate left and right, then we need to have it rotate on, I believe we're going to want it on the z-axis. So what we're going to do is we're going to create a variable, okay? And that variable will be used to rotate on the z-axis. So you're going to hit like a keyboard key, or you're going to use the game controller, and it's going to say, okay, change that variable briefly, until you've rotated the right distance, and then stop rotating. So it'll still keep doing this, but you only want it to briefly do this. So what we're going to do, for now, we'll just put the variable here. We may find that we have to turn it into a what's known as static variable later on, but we can always do that later. So public float. So we have to say what type of variable it is. It's a float, so it allows for decimals. Public float, and we'll call this z rotate, and it's set at 0. We're going to come on here, we're going to put in, and there it is, z rotate. Now we're going to save this, even though we really didn't do much, just to make sure we didn't break that z rotation. Make sure we don't get any error messages down here. And sure enough, it's still scrolling like normal. So what we want is we want you to be able to hit a keyboard, and that will cause it to rotate on the z-axis. So let's use the A key, simply because a lot of games use WASD controls. So public key code, and it'll be con Z for control Z. Actually, let's type out control Z. And that is going to just get saved, and watch what happens. So the sphere has the script attached to it. The script added the new variable, control Z, and now what you do is, because you said it's a key code, it's looking for a key binding. And we said we're going to use the A key. So if you press the A key, then we want this variable to change. So I usually get this wrong, so let's say we're going to make it negative. So this is in the start section, okay? What's going to happen is we're going to have to move it into the update section. That way it's constantly checking for this. So let's copy that, paste it. Now technically, doing this is a little bit resource intensive. So there'll be people who say, well, turn this into a variable. You can. I find it a little bit easier to explain if I don't do that, though. So, in the update section, so unlike the start, this gets checked every single frame. So if, we're going to be looking for input from the player, so if input dot get key, so get key means as long as the key is pressed, this is true, whereas get key down is only true for a single frame. So input.getKey, and then it's that Control Z variable we created. So what this is saying is, if this is being pressed, then we want something to happen. We want Z rotation, or Z rotate rather, to be set equal to, let's try negative 0.2 F. And then if it's not being held, then we want it to be, for the moment we want it to be 0. So what we'll do is we'll put in else. We'll have to modify this. Again, this is just to demonstrate how to do the rotation, and when you're letting go of the key, it shouldn't continue. So Z rotate equals 0. Okay, let's see if there are any errors. Don't seem to be. So let's give it a run. And when I see the trees, I'm going to hold A. And sure enough, it does start to rotate, but really not enough. It was kind of diagonal. So we'll make this like 0.7. So 3 times the amount and then some, 3.5 times the amount. And what I'm doing now is really just game balance. Once you know it functionally works, it's just game balance as to, see, like that was really fast. Now maybe you want it to be that quick. Do this one more time. Obviously, I'm trying to like dodge between the trees. All right, that's a little bit better. That's more balanced. Now, it doesn't look right now quite right because there's no animation on him. So what's going to happen is the character will have like a rotate animation. And let's go ahead and add that rotation. It's basically a placeholder functionality because, like I said, eventually you're going to have a character that, the arms and legs are independently animated and that kind of thing. But for now, at least we can carve out the code to make it happen. So right now we have a script attached to the orb. Well, that doesn't do us any good because the character is not a child to the sphere, so we need to have its own script. So right-click, create C# hero con. We'll click on the hero. We'll attach the script, and we'll open it up. We're going to use something known as Euler angles, and what it does is it lets you do a rotation, and it's an absolute rotation, so it ignores whatever rotation it is. It just says, okay, starting at a certain point, whatever the default point is, you're going to rotate it 90 degrees or 80 degrees or 20 degrees, whatever. So we're going to do a similar kind of setup here. We're going to do public key code, and it's going to be, so public key code, and we'll call this rotate hero. Save that. Go to our hero character. Here's a script, rotate hero, and what we're going to do is we're going to once again check for A. So you're going to actually have two different checks for the same functionality. There is a way to consolidate it, but it doesn't hurt anything. You'll see. So, if, this is going to look familiar because we just had a similar statement to this. So if input dot, and this one we can do, yeah, we're going to keep it rotated the whole time. So get key, and this time it's rotate hero. If it's true, then we want something to happen. We want transform dot Euler angle equals U vector 3. So he's going to rotate on the y-axis, on the vertical axis, like a pole. So going to rotate left. So let's, I believe it's like positive. Actually, let's do negative. Let's try negative 45, 0, 0. Save it. Now, we don't have the else to turn it back. I just want to make sure there's no errors with the code and that this actually works. So now when we hit the A key, in addition to rotating the orb, he should rotate 2. And he did rotate, but the wrong one. So, oh, sorry, I said, my apologies. I said Y, and then I want to put it in the x-axis. So, do as I say, not as I do. There we go. So again, doesn't look spectacular. The angle isn't quite right, but the functionality is there. So now we'll just do else. And again, this is placeholder because for other, not only do we not have the final animation, the final character, but we also are only checking for the A key. I presume we're going to give you the ability to rotate right as well. Although by having the camera point down, it actually looked better. And press left. There we go. Okay, that should about do it.